Hello, my name is Nestor, and today I wanted to talk to you about how to code fearlessly. Let's say that we have a function to cook in the oven. I'm hungry today, I already tested this with an apple pie, and now I want to test it also with popcorn. However, a regular oven doesn't have a microwave functionality, but we're going to implement this within our function. This function works together with others, creating a script, and my job as a programmer is implement this new feature without breaking the whole code. This is something completely different from writing docs, because when I'm writing docs, I can just change something and just edit it back later and it doesn't matter. But with code, it can actually break. So how do we do this? This is quite similar to Jenga because we have a structure that already works and we want to make it change a minor adjustment, but we don't want the whole thing to collapse. So our stakeholder might be very confident, very happy if he doesn't have any clue or she doesn't have any clue of what we're doing, but we're actually quite nervous trying to code in such a way that it doesn't screw up the whole thing. Now deployment day arrives, the new feature is live, we made our best, we coded everything, and it's time to make some apple pies again. So all the functions run, 1, 2, 3, it reaches ours, boom, the whole thing crashes, code doesn't run, our apple pies are burned to a crisp, and we're kicked out of our jobs. So, okay, this sucks, right? But what can we actually do about it? So in the development phase, I want you to imagine that you have a secret or a special button that can tell you if the function works or as expected, or if it doesn't. So if it works, there's going to be a green light, and if it doesn't work, there's going to be a red light. And I can press this button as many times as I want to just check that my function works. And this would be quite convenient because as I'm coding, I'm just checking, okay, it works, okay, it doesn't, and I'm making my adjustments. So you may say, sounds really cool, I have to say, but how do I actually implement it? You implement this with unit testing. And unit testing is about testing one unit, so one thing. In this case, it's going to be a function that we're going to test. This is why it's really important that they are as small as possible. And we're going to say, hey, we have this input, this raw apple pie with all the ingredients, and we want to check that the apple pie is actually cooked, it has a golden color, it's actually perfect, right? And then our test is going to pass. And on the other hand, if our pie is completely burnt, then our test is going to fail. So it's just setting up a test saying, this is the input, we're going to call the function, and we expect this output. Works, green, doesn't work, red. And you may say now, okay, very insightful, but how do I structure my tests? We're going to follow the 3 A's rule or guideline, and this is first to arrange, secondly to act, and lastly to assert. How this works in a Python example would be to set up first arrange. We're going to set up our input or everything that we need for our functions. We're going to get our apple pie created with the ingredients. We're going to say that is cooked is actually false and that the color is brown because it hasn't been cooked yet. The second part is where we act. We say, okay, we're going to use this apple pie with this configuration, and we are calling the function. So we have the input, now we are calling the function. We receive our output, the apple pie here. And lastly, we assert. This is the most important part. Here, we check that our expected output is the output that we got. So in this case, the apple pie, the color is gold, so it's perfect, the color is perfect, and we check that it has been cooked. We can write multiple of these small tests to make sure that this function works and just run it every time we want to check if it works or not. This is an example in Python, but if you want to see how to program it with other programming languages, I suggest you just Google unit testing and then your programming language, and that will help you out. And lastly, you may say, okay, this is really convenient and all, but I will waste time writing tests. Sometimes I just need to develop this little something really quickly, and this will really slow my work. And to answer to that, I would say that the only way to go fast is to go well. it's much better to check every function and every feature that you are developing, so in the long term you don't have any problem. And otherwise, if you don't create any test, this is going to pile up, right? So imagine that you have 4 features, maybe the 4th one is going to fail, and you don't know if it's the 4th one, 3rd one, 2nd one, or 1st, right? So it's much better to build the foundation first, and then just rest assured that all your tests are going to run. Now let's look at this example again. It's quite different from now that we write tests, right? Because right now we're really confident, we're really calm, we build our tests, we know that the function that we develop works, and we know that when we deploy it, it's going to work. So we're still making these little tweaks. It's going to be hard to make these little tweaks, but we can be very calm and confident that it will succeed. And lastly, I would like to leave you with this rule for coding, and it's that your code should run all tests. So at all times, when you write code and then when you want to deploy it, your code should pass and should run all the tests. So that's it for today, a very short video. If you have any questions regarding something that I have explained in this video, just leave me a comment or some tips or just some reaction. And yeah, see you on the next video.